All right. So the last lecture we had was kind of an overview of approaches to information systems development, and this chapter is going to go into a little bit more detail about the methodologies and the specific tools and techniques we can use in all these various ways of going about systems development. There's kind of two broad categories that we're going to address, and I alluded to them in the last lecture, but this time we're going to go again into some more detail. So the two broad categories are the predictive and adaptive SDLCs. So with the predictive SDLCs, it's you kind of know ahead of time, or you feel like you can get as much detail as you can ahead of time before you go and do the actual development. Versus adaptive, you're saying you don't know what they are and you know they might change over time, so you're going to have a more flexible approach to it. We're going to look at the various activities, and you'll see a lot of overlap in these. Like, you're generally going to see various combinations of planning, analysis, design, implementation. Those are the broad categories you'll see repeated in a lot of these, but just kind of put together in different ways. The specific models that we'll be building in each of these stages, and the steps in which we come to those models. These are the methodologies, the tools that we'll use to build the models, and the techniques for gathering data and things like that. We'll also look at Agile, Unified, Extreme, and Scrum, and we kind of looked at that last time. I had those short videos that kind of gave quick overviews, but we'll look in more detail on these steps. So as I said, there are two general approaches to developing systems. With the predictive approach, which usually takes the form of what's called the waterfall model. Again, you assume you can plan everything in advance. You assume that you could know ahead of time all of the blockades that will come and slow it down, all of the staffing issues that you might have, all the technical issues that you might have. And I would say this approach is, you're a little prideful to think that you would be able to do that. Any organization is generally going to be more complicated than this would assume. If you're very certain that the requirements are well understood, like, there's going to not be any surprises, you're not really bringing any new technology into the system, you might want to go with this because it's a pretty simple model. But I still think that it's unlikely that you actually would and could know this. All right, and then as opposed to that, to the predictive approach, there's the adaptive approach, which is the so-called iterative model, as we've talked about. And in this one, you assume that you don't know, and that the project must be more flexible and adapt to changing needs as the project progresses. This is best suited when you don't really know for sure what the requirements will be, and that you also are not confident on what the technical risk might be. So if you're, say, for example, you want to introduce a smartphone interface for an organization that maybe didn't have it before. So there could be all sorts of things, particularly when you think about security and, you're dealing with the smaller screen. So the interface is going to be different, and perhaps a touch input. So that would be a pretty high technical risk, as opposed to we're building a standalone application to replace an existing standalone application. With that one, there would be a lower technical risk. And so you might consider the waterfall method instead. Generally, there is some form of continuum. So what this means is that it's not necessarily a binary choice where you would say something is 100% predictive versus 100% adaptive. You could fall slightly more on the adaptive side or slightly more on the predictive side. How that affects your methodology, you can mix and match a little bit, but generally you have to kind of pick a methodology, and you pick the one that best suits your understanding of the requirements and the technical risks at hand. Whether or not it's very strongly predictive or very strongly adaptive, you still have to pick a methodology to go with. So with the traditional approach, this is the predictive approach, and it's called traditional because it was the de facto standard for decades. There are papers originally written on this going back to the 1950s, and it became the de facto standard probably by the early 1960s, and stayed that way until the early 2000s. So it was, for a long time, it was what you did. That there was no question about it. It was just what you did, and that's why it was called traditional. And putting it on that kind of opposite spectrum and saying it's predictive is a little more descriptive than just saying traditional. But anyhow, you have these sequential phases, and by sequential, what it means is that you can't start a given phase until the previous phase is finished. And you'd see your standard phases here, as we've talked about: planning, analysis, design, implementation. The text mentions deployment as a separate phase. Generally, deployment could be considered as a part of the implementation phase. And the way we do this is with the waterfall model. And as I said, in order to move on to a phase, so say I'm in planning, I have to be completely finished with planning before I start gathering the metrics for the analysis phase and turning those into use cases and things like that. And before I start building models in the design phase, I have to be completely finished with all of my requirements gathering that I would do in the analysis phase. So this assumes that there's no overlap or iteration. So you're not going to be looping back and saying, okay, we're going to deploy kind of a beta version, and then we're going to go back and replan and reanalyze and redesign. Let's assume that won't happen. What you release is the final product, is what the assumption is. And that's it. And that's kind of why they use the term waterfall, because with a waterfall, you tend not to go back up the waterfall. Once you go over, you're done. And if there's steps of waterfalls, as you fall down each one, you're stuck in that phase. This is a pretty rigid approach to things, and certainly could lead to all the failure stuff that we talked about last class. Here we see an example of the waterfall method, where you see project initiation. So this is kind of where you put a proposal in. That falls into project planning, where you would get approvals, you would get funding, you would do like Gantt charts, plan out the schedule, plan out the personnel, things like that. And once that's set, then you fall into analysis. And notice it says the initiation and planning specifications are frozen at this point. So you cannot change them once you go into analysis. Once you do all your analysis steps, then those are frozen when you fall into design. Design's frozen when you fall into implementation, and implementation's frozen, and it's built exactly the way it's planned. And finally, then that would go into deployment. And you'll see here as well that these core phases can be split out into separate phases depending on the needs of the organization. Like in this example, they've separated out project initiation out of project planning, when other times initiation is considered part of the planning. Part of my plan is to do the proposal in the first place, whereas others say, well, you can't plan anything unless you've initiated it beforehand. So it's a little bit semantics, but again, there's 4 core phases, which are planning, analysis, design, and implementation. And those can be broken out a little bit as needed, as we see in this example. There is also a modified waterfall. So as the decades passed and they started to see, this is far too rigid for most organizations. Organizations are groups of people that have essentially a social contract. And this social contract is wrought with interpretation. And interpretation can be different among different groups of people. Therefore, all of this complexity and the challenge of understanding it is not best suited for this rigid process. So the early steps before we move more into the agile, iterative, adaptive type of approaches were to say, okay, let's not say that everything's frozen as we move from one step to the next. Why don't we allow for the fact that after I'm mostly done with project planning, notice there's that green diamond right here, this first green diamond that says, this is a decision point. And my decision point is I have sufficient planning to start doing the analysis. But you understand that there may be additional planning and control that happens through the duration of the entire project. With analysis, I have a decision point where I start moving into design. I say I have sufficient metrics gathered, requirements gathered, use cases created where I can begin the design. But I understand there may be additional analysis tasks, not through the duration, but for a significant chunk of it. And then in design, I can move into implementation once I have sufficient design completed, but I might be moving back and forth between implementation design, even all the way up to planning as needed. So there was this kind of more flexible approach, but it still wasn't considered that the product that comes out of this is going to be anything other than a final product. So there still was that underlying assumption, which still had some rigidity to it. Most software development done today makes the assumption that the product that comes out is definitely not the final product. There will always be patches. There will always be updates. There will always be enhancements. There's always these things that will happen that you'll continue to cycle through these steps. Whereas even their initial tweaks to it, which would be probably late 80s, 90s that you started to see these tweaks to it, were a good step, but maybe not enough. So eventually we started to consider the need for adaptive systems development life cycles. I don't know if I really agree with this first point, which is from the text that says emerged in response to increasingly complex requirements and uncertain technological environments. What I don't agree with is I don't agree necessarily with the fact that the requirements were increasingly complex. I think they always were complex. I just don't think people had a mature concept of what it meant to model an organization. There were very large organizations in the 1960s and 70s. It's not like it's a brand new phenomenon that we have large organizations. Even in the 1930s and 40s, there were very large organizations. So I think the requirements were always complex. We just didn't have a mature understanding about that. And again, the textbook doesn't reference this at all, but there are very high failure rates for new IS projects, even still today. And I think that was more of the driver, the fact that we had these high failure rates versus what the textbook is saying, or at least implying, that things got more complicated. I don't think I really agree with that. Anyhow, with the adaptive SDLC, you're going to have a lot of the same steps. You're still going to have, design and analysis and implementation. But now we're considering it, instead of just this start and finish and you're done, it's more this iterative approach where you're thinking, okay, I'm going to be looping through it. And every time I come to the top of that loop, a new product might come out, or an enhancement to an existing product might come out. I would say this third point, yeah, it's true. But I think it leaves a lot open to interpretation what the author meant by many developers claim it's the only way to develop information systems. That's true, but there also are many developers who claim that waterfall is the only way to develop, even today. Waterfall is the only way to develop information systems. So I'm not sure exactly what they meant by that. Yes, people are biased and prejudiced with concepts for sure. But nonetheless, I suppose it's true. And it says at the very end, there are many IS managers are still skeptical due to apparent lack of overall plan. I think he actually makes a good point here, because managers like to control everything. They don't like adaptation because they believe it takes the control out of their hands. So it really is more of a power relationship thing than a manager considering what's actually best to get the project out. I think it's more the prior than the latter, or I'm sorry, the prior than, or the former than the latter. So yeah, there certainly is some skepticism there on the managerial side for this newer approach. So a core concept to the adaptive approach is that you're not developing the entire system start to finish, that you're doing this so-called incremental development where you're creating parts of it with each loop of your methodology. There are different ways to do this. One is, as the text calls it, a walking skeleton, where you build the entire structure, but it's not deep. It doesn't do everything. You could walk through it, but there's only going to be very basic things that it completes. Another approach is to do like a prototype approach where you build individual but complete subsystems and then grow that from there. So let's look at the methodologies, models, tools, and techniques. So with the methodologies, these essentially are your guidelines. What are my steps and how do I go through these steps? What specific SDLC will I be using? In terms of the project planning and project management, for models and reporting, what models will I be creating for my analysis and design? What are my techniques I'll be using for implementation and testing? And then finally, my deployment and support techniques. So it's just essentially a set of guidelines for how you're going to do the entire project. So what is a model? There's a whole chapter on this, but in short, a model is an abstraction of the world. If I am, for example, storing data about something, a model might indicate the structure in which the data is going to be stored. Earlier on, we had these things called flat files that, if I wanted to keep a record of orders for a company, at a very superficial level, it might make sense to say, okay, well, I'm going to have fields for that record that would include what I sold, how much it cost, who bought it, things like that. And that's a very simple model, as opposed to saying, why don't I have a model that shows a relationship between a group called the customer and a group called the order, where I'm not having to repeat the customer information over and over. So these are the things you're thinking about with a model, and you're not getting bogged down with technical implementation. That comes after. The big point to the model, as it says in that last sub-bullet point, is communication. Again, the systems analysts, their main focus is to communicate, kind of be a liaison between the users of the system, or the eventual users of the system, and the developers of the system. And the way they facilitate that is through the building of models. And the point to the model is to communicate in a technical way what the user wanted to the developer. So some examples of models that we'll be using in here: use case diagrams. I think you guys have done a lot of these in this little mini project from the second week. The domain model class diagram, design class, sequence diagram, package, screen design, dialogue design, storyboard, and entity relationship diagram. So this would model the system components from on the process side, in other words, the logic. You might include the sequence design class diagrams. On the data side, you might include the entity relationship diagram and the design class. And then from the interface side, you might have the dialogue design storyboard and the screen design template. So they all have a place as to why you have them. In terms of managing the development process, I've already mentioned the Gantt charts. So these are essentially scheduling tools that you use to say, if you have dependent tasks, like I can't start this until I finish this, and so on and so forth. The Gantt chart is helpful to plan that out. The organizational hierarchy chart. This one is important. It gives you an idea about the place of people in organizations. And when you're in the analysis phase and you're gathering data, it's important to know that you have a broad distribution of people when you're gathering data from your interviews, and the organizational hierarchy chart can help with that. Financial analysis models, this can help with your budget planning for the project. The life cycle model, how are we planning this out in terms of the steps? Are we doing iterative, adaptive, predictive, agile, extreme, whatever your model is, it gives you guidance as to how you're going to run through that. Stakeholder list, it's pretty related to the hierarchy chart. It just kind of shows you, who you need to talk to. And then finally, the iteration plan, which is closely tied to the systems development lifecycle. It just gives you the steps for how you're going to run through the project. So the tools, what software am I going to use? We're not going to write everything out on paper. So what type of IDE am I going to have for writing the code, and what software for the Gantt charts, and what about model building? Do I want to have software for building my models? Do I want to use Rational Rows, or even just a simple drawing program? Or Oracle has some software you can use to build your models. So these are all tools that I can use. There are project management applications that kind of package it all into one piece, all of these planning tools in terms of the finance, the organization, the scheduling. It all puts it into one, which is convenient for managers that are making these decisions. Because models are essentially drawings, I might want an application for that. Of course, a word processor. I could be a little more sophisticated with a visual modeling tool. I've already mentioned IDEs. Database management. These last two, I would say, are controversial. Reverse engineering and code generator tools. I don't know if you guys have ever been exposed to reverse engineering or code generator tools, but they're not very good. With reverse engineering tools, at least some of them, you can take an existing program that maybe you don't have the source code for, and it will pull out a version of the source code, but it's almost impossible to work with. There's no structure to the code. Generally, it's in a language called assembly, which is needlessly complicated for most applications. For example, if you wanted to do a simple addition, which would be one line of code in any other language, you might need about 20 or 30 lines of code in assembly. So and that shows you a simple thing that would be way overdone. Imagine a complicated thing. And then the code generator, these were actually really big in the 80s. There was something called CASE, which stands for Computer Assisted Software Engineering. And most people in the 80s believed that programmers would be extinct by the early to mid 90s. There'd be no need for programmers anymore because we had software that wrote software. And the problem was that it was terrible. It never wrote good software. It never came even close. It wasn't even like it was 90% good. It was 10% good. And then you had to pay a programmer to rewrite the code, essentially taking twice as long as if they just written it in the first place. And of course, that wasn't sustainable. And eventually the code generators, they just stopped working well. I guess I could show you something really quick to illustrate this, a simple code generator thing. All right. I'm sure a lot of you guys probably know basic HTML, and I'm hoping you can see my screen right now. So I'm going to write just like a hello world. All right. Okay, so let's save this. So this is some basic code here. And here's the file. So I just saved it as test.html, and you see it just says hello world. So if I wrote this raw with the code, it's 5 lines of code, very basic, very simple. And if I go into Word and I center this hello world and I bold it so it's exactly the same, and I do essentially code generation where I say I want this as a web page, so HTML. And we'll save it to the same place. We'll call it test2. So here's test2. It's similar, slightly different font, but it essentially does the same thing. But if we look at the source, so the code that this code generator created, you see it's a little bit longer than the code that I wrote for almost the same thing. And this is the type of thing that happens with code generators, is there's so much more code than is what is needed. So if you actually need to fix something, which code generators can't do, they can't fix anything, you have to hire a programmer that now has to go through 100 times the amount of code that they would otherwise. So, code generators, I would definitely consider them controversial, and to list them as a typical tool, I'm not so sure about that. All right, let's move into some of these specific ones. So agile development, it is a guiding philosophy. I like that there are specific guidelines. I think the philosophy is a little bit much, but it is what it is. It revolves around the extreme end of knowing the requirements or not knowing the requirements, and it assumes not knowing at all, and massive continuous change. So in other words, you have to be agile to work with that. Chaotic, or this is chaotic yet ordered. This is the kind of the guiding principle of agile development. So the focus is not so much following a plan, but being able to respond to change. So there is a plan, but it's not overriding. It focuses on individuals and the way they interact instead of just the processes and tools. And it wants something that works. In other words, the actual software should work. Much more important than comprehensive documentation, which a lot of the older methodologies, where it was you have to have perfect design, perfect analysis before you move on, and saying that you should do the documentation, but that's secondary to having the software actually working. And then finally, you should value customer collaboration. So getting the customer involved, and the customer could be someone that you work with even. I say client might be better. So client collaboration over contract negotiation. So in other words, have them work with you instead of fighting against them is one of the values for Agile. 12 basic principles. Minimize modeling, yet also model with a purpose. So make sure that what you do is done well. Embrace change. Software should be your main focus. I find some of this stuff a little contradictory. I'm trying to be positive about it, but if you notice, this one of the 12 says minimize modeling, and then down here it says build multiple models. It's a little contradictory, but I get the spirit of what they're saying. Don't do unnecessary planning, essentially, is what they're saying. Build your models with very high quality, and focus on the content, communication, learn from each other, know your models and how to use them, adapt to specific project needs, and then finally maximize stakeholder ROI. So ROI, as you all probably know, stands for return on investment. So make the stakeholder, the person that you're building this for, feel like they're really getting something for their money, and it's something that's worth their while for you to be building for them. And again, some repeated stuff here. So software should be the main focus. Don't get distracted by the documentation. Enable the next effort as your secondary goal. So in other words, your iteration should be always in the back of your mind. Your main focus should be building the software for the first step, and in the back of your mind as a secondary goal, what's the next thing going to be? Minimize your modeling activity. Only build what helps the project move forward. And embrace change. So, when you make a plan and you want to move forward with it's honestly, psychologically, it's difficult to accept the fact that it's not going to be what you planned. Humans are generally resistant to change. So with the agile approach, it's saying, embrace that. Don't just accept it, but say, this is good. This is something that is going to make the best product. So I'm embracing this thing that normally I wouldn't like. Most humans don't like change. Model with a purpose. So make sure everything you do has some meaning. Make sure that you are very clearly looking at the user requirements and putting those into models that a developer can use well. You should look at problems from different perspectives. So building multiple models can help with that. And of course, you'd want high quality models and focus on the content rather than the representation. Always be focusing on what the stakeholder needs are. Don't build something just for the sake of building it. Open communication is very important. You got to learn from each other. You should definitely know your models. And as your project moves along and changes, be ready to adapt. Be ready to change what the project is in order to understand the current state of what the organization is. And then, as we said before, maximize your stakeholder return on investment. All right, let's move on to the unified process. So this is one of the older of the adaptive processes, and originally almost became a de facto standard. There even was a language that was developed at the same time as the unified process came out, the unified modeling language. And it was supposed to be an all-in-one type of thing. So we have a lot of the same phases. They call them something a little bit different here. The inception phase, this is kind of like your planning phase. Your elaboration phase, this is essentially your analysis phase, and construction is building. So you might ask, well, where's design? It's kind of in the latter half of elaboration and the first half of construction. So they've kind of, as I said, oftentimes you see things mixed and mangled, but it's the same core concepts. And then we have transition. This is preparing for and moving to deploying the new system. Essentially the latter half of a normal implementation phase where you do the rollout. I think it's good that the unified process makes this a distinct phase, because that can be traumatic for an organization to do a transition, because everyone's used to doing things a certain way, and now suddenly it's going to be different. And for a lot of people, that can be traumatic. They don't necessarily like that. So here we see a diagram showing those four phases: inception, elaboration, construction, and transition. You'll notice that they've split out different iterations within each of these phases. So they're kind of sub-phases where you're going to do this iterative process within the phase, which is a little distinct from other phases where they say the entire development lifecycle is the iteration. Here they're saying the individual phase is the iteration, which is pretty unique. So the objectives for each of these four phases, a lot of this should look familiar to you guys. So with inception, vision, you guys might recall doing a vision, making a business case, defining the scope, estimates for cost and schedule. You see a lot of planning stuff in there, right? With elaboration, now you're going to whittle down that vision to something very specific. You're going to gather all the requirements. This sounds like analysis. The core architecture and functions, resolve the high risks, and produce realistic estimates for cost and schedule. And in construction, you're going to iteratively implement the lower risk, predictable, and easier elements and prepare for deployment. And finally, in transition, you've completed the beta test and deployment so users have a working system and are ready to benefit as expected. So for the disciplines, these are a set of functionally related development activities. Each discipline are all the activities related to achieving one objective in the development project. So two types of disciplines here. We have development disciplines, so these are actually building, and then management disciplines where you're controlling the people that are doing it or you're managing them. So within the development disciplines, so these are the people actually doing the building. You have the modeling, what are my business requirements? What is a model to describe those? The actual requirements themselves, designing, implementation or the actual build, testing, does it work the way I expect it to, and deployment. When I roll it out, are people going to accept it? These is where you have the acceptance tests and things like that are going to be done during deployment. For the planning and control disciplines, change management's a big one. Managing people through change in organization is a very challenging task because people are naturally resistant to change. So doing it in a way that they accept it is something that can be quite a challenge. Project management, does the scheduling go the way I planned it to, and the budgeting and personnel, all of that? And finally, the environment. Does the organization still functioning during this process? So this is a similar chart that we saw in chapter 1, where you have your various iterations and the focus of the disciplines. These are essentially the phases, but the focus on the disciplines through each iteration. And you see the project management has a heavy focus in iteration 1 and 2, as do the requirements gathering in 2 and 3, the design in 2, 3, and 4, and so on and so forth. So as you go through your iterations, you're moving from a requirements gathering, designing, and then the implementation is as you see here, is heavy in iterations 4, 5, and 6. But you're iteratively building more and more as you go through, with less of a focus on your analysis and design and more of a focus on the actual build as you move through these various iterations. All right, so that was the unified process. Let's move on to extreme programming. This feels like such a 90s thing to say, but yes, it takes the best practice and extends them to the extreme. So what exactly does this mean? Well, the main focus now, instead of being on strictly requirements and documentation, is more on the programming itself. And you facilitate that through, as the core values indicate, communication, simplicity, feedback, and courage. So the planning is based on user stories, which, traditionally are called use cases, but I guess they view them more on a narrative here with extreme programming. You do thorough testing at every step, so you're not going to move past something without knowing that it works. Pair programming, so you kind of are bouncing ideas off of each person as you're doing the development. Simple designs, refactoring, so you redo and clean up as you go, and then owning the code collectively. I would say this actually is quite a beneficial thing. I've been in situations where people get very possessive of their little snippet of code that they've written and are resistant to taking any input on that. They take it very personally if people critique their code. Whereas if you say the code isn't owned by any one person, it's owned by the entire team, you tend to have more flexibility. Continuous integration. So you want to continue to grow the software. You want to have your customer right there with you, and they're going to approve things immediately as you move forward. Always be thinking about what the final system should look like. And you're always releasing kind of like mini betas quite regularly so the user can get feedback on that. 40-hour work week, that sounds pretty normal, but in a lot of development scenarios, particularly when you get towards the end of a project, it's not unusual for people to be putting in 70, 80, 90 hours a week, even sometimes 100 or 110 hours a week of work, which generally is not very productive. It has to happen sometimes, but with this extreme programming, they say that should never happen because you shouldn't have that big push because you're always releasing stuff. You have this 3-level approach with outside, middle, and inside rings. On the outside ring, you have these user stories and acceptance tests. In the middle ring, you're conducting tests and doing overall planning. And then the inside ring, this is the actual coding itself. This is where you're going to have your iterations of putting out bits of code and moving through that and pushing that out to the middle ring with the tests. And then that pushes out to the outside ring with the user stories and acceptance tests. And we see an illustration of that here where you're essentially gathering your business requirements, and that green ring where it says create the user stories and the system metaphor and the acceptance tests, that falls into that orange ring, which informs the inner ring, which is where the coding is done. And then when you have a cycle that's completed, so you have an iterative piece of code, you push that back out to the orange ring, where you do acceptance tests and you see, do the users like what I did? And assuming they did, then you might bump out to finish. If there's some more work that needs to be done, you push that to essentially the next iteration and then fall back into that inner ring. So it's a pretty fast process. Speaking of fast processes, we have Scrum. So with Scrum, it focuses mostly, so other ones, we've talked about a focus on, moving away from an obsession with documentation and into development, or how do I make developers work well? So that's kind of extreme programming. With Scrum, it's more about speeding up the process. It describes it as an intense effort involving the entire team for a very defined period of time. You want to know exactly what the user requirements are. You want to know who owns them. You want to know who's running the whole thing, because essentially, there's a lot of pressure to move very fast with Scrum. They even use the term Scrum Sprint. So with the Scrum Sprint, you have a mini project to implement part of the system. Usually, as this diagram indicates, we're talking 30 days, which for a systems development, of all the processes, that is extremely fast. That is something that 30 days when you include planning, analysis, design, implementation, all of those steps is quite fast. So the sprints, you're planning this out. You have the Scrum Master that is going to say exactly what they expect to get done in the daily Scrum. So you're going to have these meetings where you say, what did you do in the last 24 hours? Did you meet our goals to get this done through this 30-day process? And in the end of it, you would have a functional piece of software that more than likely isn't going to be the whole system, but then that's going to then feed back into your next Scrum planning meeting for the next 30 days and moving through with that. You cannot have scope creep. You can't make the system any bigger during the 30 days. It's generally frozen because it's a tough enough process as it is. I mentioned this before during the daily Scrum meeting. They're going to review, what have you done in the last 24 hours? Did you meet the goals? What are your goals for the next 24 hours? Are you going to get that done? What are things that are stopping you from moving on? And this isn't necessarily, don't think procrastinating or being lazy. That's not really what's being asked here. It's more, I couldn't get the requirements that I needed from the user. So that might be something that would be keeping you from completing your work. And then it's up to the Scrum Master now to help you pass that. So they would intercede on your behalf and try to stop that from being a hurdle for you.